Let's think about the effect of the sympathetic and parasympathetic nervous system on the eyes. So the iris is the coloured part of the eye, and the iris muscles, the iris sphincter muscles, can cause pupil dilation or pupil constriction. Now, if you're in a sympathetic fight or flight situation, do you want to be able to see where you're going? Obviously. You need to see who you're fighting. You need to see the obstacles in the field that you are using to run away. So sympathetic activity will cause pupillary vasodilation. The pupils will get wider with sympathetic activity. Conversely, parasympathetic activity will constrict the pupils. So the parasympathetic activity is going to constrict the pupils. Just remind me, which nerve is responsible for contraction of the pupils? Do you remember it was the third cranial nerve? The oculomotor nerve? The oculomotor nerve was responsible for that. So parasympathetic activity via the oculomotor nerve will constrict the pupil. And this is very important for us to know about in clinical situations, because it's the parasympathetic activity that will constrict the pupil, that's right. And while it's true sympathetic activity will dilate the pupil will also dilate of its own accord when you take away the innervation of the oculomotor nerve. So it will actually dilate on its own. So if you actually look at someone who's dead, their pupils will be pretty well dilated. And before you send someone to the morgue, it's a good idea to look in their eyes and make sure their pupils are dilated. So you shine a light in their eyes and there is no pupillary response. If there is a pupillary response, it means that person is not dead. So make sure that there is no pupillary response as one of your tests to make sure that your patients have in fact died. Now, in other situations, there can be raised intracranial pressure. And the oculomotor nerve, or the two oculomotor nerves, the third cranial nerves, go on either side of the base of the skull, the right one to the right eye and the left one to the left eye. So if there's an increase in pressure on the right side of the skull, for example, due to a space-occupying lesion, which might be expanding, causing raised intracranial pressure on the right side, that is going to press on the right oculomotor nerve. What does the right oculomotor nerve do? It constricts the right pupil. Take away that innervation because the nerve is being compressed, and the right pupil will become sluggish and then dilate. In the same way, if there's raised intracranial pressure on the left side, that will press on the left oculomotor nerve. That will stop the left oculomotor nerve from working properly. That will prevent the parasympathetic left oculomotor nerve from constricting the left pupil. Therefore, the left pupil will become sluggish and then dilate. And both pupils are supposed to respond perfectly equally to light. If not, consider pressure effects on the oculomotor nerve. Now, when you're young, it's sometimes difficult to tell whether people are attracted to you or not. And one way you can tell is if you gaze into someone's eyes and they find you an interesting, exciting, attractive person, that will cause sympathetic stimulation in their brains. And sympathetic stimulation will dilate the pupils. So if you look into someone's eyes and you find their pupils constrict, they're probably not attracted to you. If you look into someone's eyes and you find their pupils dilate, then they probably are attracted to you. Now, the bit about the nervous system, the sympathetic and parasympathetic nervous system, is entirely 100% true. That is science. I'm not quite sure what the evidence base is for the pupils dilating when someone's attracted to you, but it makes sense in theory, so do what you will with that information.